Okay, welcome back. I'm Cindy Shelton, and I'll be reviewing your Applied Math Study Guide for the final exam. So we're doing Chapter 3 now, which is the logic chapter, going over truth tables. You may have found yourself asking the question in this chapter, where will I use this? And some of this stuff does seem kind of different. Not a regular thing that you would do is to draw out a truth table for your arguments, but I ask you just to read the chapter and see that it does have value in the way that we talk, to be able to represent our symbolic language and see if arguments are valid or not. For example, if you're at a restaurant and they say, would you like soup or salad? The word or means you can have soup or salad. Now, no doubt you can order both if you want, but you may have to pay extra. The word or assumes that you're getting one or the other. But if they say you get soup and salad with your entree, that assumes that you get both. So you're paying the same price, it's included to get both, the word and. So this will help us kind of sort through some of that language that we use and write it into truth tables and see if it's valid arguments as well, but also just simple things like the way that we talk to each other. All right, so the first thing we do, number 6, asks us, is this a compound statement? So first thing whenever we do the logic chapters, we want to figure out how many statements, how many ideas are we putting together. So is this compound or not? Jerry's wife loves to wrap gifts and presents. It's really just one thought, it's just one statement. So we'd say that that is simple. The question was, is it compound? So no, it was a simple statement. But I want to go ahead and talk to you about what these other choices mean. Choice B, a conjunction, kind of looks like an upside down V. That means and. So like I mentioned with the soup and salad, if they say and, we're a conjunction. That's considered a mathematical conjunction. This is our symbol. Disjunction looks like the regular V, and we think of that as being the or statement. You can have this or that, one or the other. So either one can be true. Conditional is the if-then statements. If you do this, then you get that. If-then statements have one arrow. Biconditional have 2 arrows. If and only if, so both sides have to be the same. Now the way you can tell if something is true in a biconditional statement is they can actually be both false. If false, then false. If true, then true. The 2 sides have to have the same truth value. So same truth value. If they have the same truth value, we'll label that with a T. And this is called if and only if. Way we would say that. And then the last one, negation, looks like a little squiggle mark. Negation means to change the truth value of something, to negate what you said, do the opposite of. It's kind of like an opposite statement in language. All right, so moving on over to number 7. So we have this 2 statements, 2 simple statements. The job pays well, statement P, and statement Q, the chair is broken. 2 ideas, 2 statements. So it says, write this sentence in symbolic language. If, here's an if-then statement, so it's going to be a conditional thing. If the job does not pay well, notice how they negated statement P, does not pay well, so that's not P. Then, there's the if-then symbol. Then, the chair is not broken. The chair is broken with statement Q. Looks like we negated that, so not Q. So this would be the symbolic language for that statement. Okay, number 8, we are asked to make a truth table for not Q or P. So we have 2 statements, P and Q. Now, notice in your truth table, sometimes the truth table would be 4 long, and sometimes it would be 8 long, and I don't know that you got to a problem that had 16 long, but it could be, depends on how many statements you have to how big the truth table is. If there's only 2 statements, you're going to have 4 rows. If there are 3 statements, you have 8 rows. And that's because you want to write down all the possibilities for P and Q. P is true and Q is true. P is true but Q is false. Or P could be false and Q could be true. Or both of those could be false. That's the only possible combinations for that. Now if you have 3 statements, there winds up being 8 different combos for that. And that's why the table looks bigger. Alright, so P and Q, just 2 statements, so we have those 4 possibilities. Alright, so we want to do not Q. Not Q just means look at row or column Q and then write the opposite of that. So just have to focus on the right row. So change that to an F, T, F, T. And then you're supposed to do a compound statement of not Q or P. Now remember, the word or means it can be either one. So as long as not Q, this row, or P, this row, as long as either one has a T in it, we're going to put a T here. So what you want to do, and you may just want to even blot that out, mark that out, try not to look at that. Only look at column P and the not Q and do the or statement between those two. So I'm thinking either one of those is a T, I'm going to put a T. So definitely both of these are false, and then one of those is true. And then that's all you need to do to fill in that last column answer. Okay, number 9, another truth table. Notice we have 3 statements this time, P, Q, and R statement. And really those can be any letter. There's no magic in which letters you use, but these seem to be the ones they use the most in this chapter, but any letter would be fine. So it says, I dress quickly. There's a thought. We'll call that thought P or statement P. And take the express train. We'll call that thought Q or statement Q. And I do not get to work on time. Our third thought, or our third statement, we'll call that statement R. So we want to do the compound statement, and ultimately the last part of our truth table is to figure out that whole thing, but we do it a piece at a time. So first of all, it says fill in your P, Q, and R and all your combinations of that. Got to get my paper. So this is filled in though on Math Excel. You already have this yourself. So the first thought, all 3 of those could be true. The first 2 true, the last one false. True, false, true. So if you were wondering where all this came from on Math Excel or in the book, it's just all the possible combinations for these 3 statements, all the possible truth values. And then lastly, all 3 thoughts could be false. All right, so first column it asks us to do P and Q. Now remember, if you do P and Q, the upside down D, the and statement means they have to both have a truth value of true before we can say T. Both of these occur. So P and Q, and so we're not looking at this column, just ignore it. T, T, so that's T, 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 T. A true and a false, so that's false. True, false, so that's false. False, true. False, true, false, 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 false. Okay, so both of these columns had to have a T in it before I could put a T here. All right, and then the next column on Math Excel says fill in not R. So now we're going to focus our eyes on the R column and fill in the negation of R. So change that to its opposite, opposite, all the way down. And then lastly, and I should mention, this comes from what is said here. I dress quickly, statement P, and take the express train. And is in conjunction, so the upside down V. There's that first part of the problem, and it has a comma which says those 2 go together first, like do this first. Then do this and I do not get to work on time. So we're negating a statement R. And that's where this last column comes from. Doing P and Q, this column, and with a not R. So we're focusing our eyes on these 2 columns, and we're doing an and of those 2. So remember, when you do an and, both of these have to be true before we can say true. So true, false, we'll say false. Notice both of those are true, so we can say true. So there was only one place where that was true, where both of those had a truth value of T. And let's see what else it asks us to do. So then, as the last part of the question, it says, use the truth table to indicate the set of conditions that makes the compound statement true, or state that there's no such condition that exists. So if all of this final output would have been F, we say there's no way that this even exists, this statement can't happen. But there was a possibility right there, so we read over what were the conditions of the statements, and it is choice D. Actually, I should mention, the study guide that I have in my hand, I printed off Math Excel. It regenerates every time someone opens it and asks different questions, so yours may not be the exact same problem, but it should be very similar. But anyway, for my question 9, it is choice D. The statement is true when P, okay, so the statement is true, and then I read over here where P and Q are true and R is false. So I can read over what were the conditions over here that made that true. All right, number 11. So the last two of the truth value or the logic section is trying to decide if the statement is valid, if the argument was valid or not. Now this is really the good stuff, and I just barely skimmed the top of it, so I do encourage you to get deeper into this. Read on Math Excel. Anytime you open a homework problem, you can click View the Textbook, and you can read those pages and page over and read all you want. If you don't feel like you get the full spectrum of the information there, you can always go on the web and Google logic and read more about it. Or I recommend the Khan Academy, K-H-A-N Academy. And it has all kinds of resources that seem to be just really good, trustworthy information where you can read up on other topics. Okay, so our two problems that we're going to decide if our logic is valid or not. Number 11, it gives us a biconditional statement, P if and only if Q. So that means these have the same truth value. Remember, biconditional, the truth value has to be the same. Either both are false or both are true. They lead to the same answer. So if Q, then R. So we're saying Q has happened and it led to R. So would it be valid to say, if not R, then not P? So not R would mean not Q couldn't have happened, and Q has to have the same truth value as P. So you can kind of follow the thought process up through there and say, not R would mean that you couldn't have had Q, and Q is the same thing as saying P, so you couldn't have P. So that logic is valid. So we should say valid for that one. Okay, one more, number 12, written out in words, and then we have to do our own symbols. It says, if you do a good job, so I thought P, then your boss will be happy, thought Q. So if your boss is happy, that was thought Q, then your boss will give you a raise. A new thought, a raise, that's thought R. So writing this symbolically, we can say if P, then Q, and then we did Q, so Q led to getting a raise, R. So is it valid to say if P, then R? If you do a good job, then you get a raise. And the logic did follow through. We're saying if P, then Q happened, it led to R, so P must lead to R as well. That is a valid argument. Okay, that's all for chapter 3.